In this video, we're going to look at parallel and orthogonal vectors. So first of all, if we talk about two vectors u and v and they're perpendicular, then that means that the angle between them is 90 degrees. So remembering my formula for the angle between vectors, which is cosine theta equals u dot v over the magnitude of u times the magnitude of v. If my angle between my vectors is 90 degrees, then I have cosine of 90. The cosine of 90 I know is going to give me 0. So then I have 0 equals u dot v over the magnitude of u times the magnitude of v. And then if we multiply both sides by that denominator, then this will cancel out over here, and 0 times anything is still 0, so we end up with that u dot v equals 0. So anytime I have two vectors where the angle between them is 90 degrees, which we refer to as perpendicular, then I know that the dot product will be equal to 0. In order for two vectors to be perpendicular, both vectors have to be non-zero vectors. So in order to have an angle between two vectors, remember we have to have two non-zero vectors. Okay, so a definition of orthogonal is that the vectors u and v are orthogonal if and only if the dot product equals 0, so u dot v equals 0. So this appears to be saying the same thing with my dot product equals 0 for perpendicular and my dot product equals 0 for orthogonal. So perpendicular vectors must be non-zero vectors. Orthogonal vectors, on the other hand, can include the 0 vector or be perpendicular vectors. So orthogonal vectors are including all perpendicular vectors. So all perpendicular non-zero vectors would be considered orthogonal, and then any two vectors where at least one of them is the 0 vector would also be considered orthogonal. So you can kind of think of it this way. So we have this set of vectors that are the perpendicular vectors, which will give me two vectors where the dot product is 0. And then we have a slightly larger set that includes the whole perpendicular vector set, which is orthogonal vectors. So all of those vectors inside the blue region there, but outside the orange region there would be the vectors where at least one of the vectors is the 0 vector. So two vectors u and v are parallel when the ratio of the horizontal component over the vertical component is the same for both vectors. So essentially you're just taking the y value over the x value, because in order for two vectors to be parallel they have to have the same slope of that line segment. So really you're just doing y over x for each vector and seeing if they're the same. Alright, so we're going to look at some examples where we're going to look at vectors and decide if they're parallel, orthogonal, or neither. Alright, so in this example we're looking at vector u, which is 2, 3, and vector v, which is negative 6, 4. So if we draw these out, it appears that these two are perpendicular. So we're going to go ahead and test for perpendicular. So remember, if the two vectors are perpendicular, or what we're going to refer to with vectors as orthogonal, then we're going to test if the dot product is 0. So to decide if these are orthogonal, we're going to see if u dot v equals 0. So I'm going to do the dot product of 2, 3, and negative 6, 4. And I'm going to see if that equals 0. So this is going to give me negative 12 plus 12, which equals 0. So since the dot product equals 0, so u and v are orthogonal vectors. So here's a second example. In this example, we have vector u, which is 10, 8, and we have vector v, which is negative 5, negative 4. So you can see when we graph both of these that these vectors appear to be parallel because they have the same slope. So remember, to show that they are parallel, what we want to show is that the slope of the line segments or the ratio of the vertical to horizontal component is the same for both of them. So to show if two vectors are parallel, what we want to do is we want to show that so v2 over v1 is the same as u2 over u1. So remember, horizontal and vertical components. So I'm going to take negative 4 over negative 5, and I'm trying to test and see if that is the same as 8 over 10. So this gives me 4/5 is equal to 8 over 10 reduces to 4/5. So they're equal, therefore u and v are parallel. In this last example, we have vector u is negative 4, 7, and vector v is 8, negative 1. So it appears that they're not parallel. They may be orthogonal, so we're going to check. We need to show which they are, so we have to prove one way or another and show it. So first we're going to test for orthogonal. So we're going to test the dot product. So my dot product is -4 times 8 plus 7 times -1, which is going to give me -32, plus -7, which gives me -39, which is not equal to 0. Therefore, U and V are not orthogonal. Next, we'll test for parallel. So we're going to test whether the ratios are the same. So does -1/8 equal 7 over -4? Obviously, these are not equal. Therefore, these are not parallel. So U and V are neither parallel nor orthogonal.